Welcome to science class. Today we are going to discuss weather and climate. Most of this video is about climate and the factors that influence it, but we will be learning what the difference between weather and climate is and how weather informs us about climate and vice versa. We have covered a lot of this before. We learned how ocean currents drastically alter the climate of an area. We have learned how the shape of the planet produces unequal regions of heating on Earth's surface. So, luckily, a lot of this will be review, which means we can go further and learn about other important things. Let's get started. We are going to begin with weather. Weather is whatever state the atmosphere is in right now, in a local area. Is it raining? How hot is it? What's the wind speed? What's the humidity? Those things are all weather. The weather changes every day, every hour, even by the minute. In 1943, in Spearfish, South Dakota, the temperature increased from 4 below to 45 degrees in 2 minutes, which is a world record. In 1911, in nearby Rapid City, South Dakota, the temperature dropped 49 degrees in a 5-minute period, another world record. Normally, weather isn't that unpredictable, but weather is volatile. It's subject to change. You should think of weather as individual points of data. By themselves, they can't give you the big picture of what's going on. You need to collect huge amounts of data on the weather in order to do that. That's what climate is, the long-term average of weather patterns. Here's why this is important. We know the planet is getting warmer. That's what the climate data tells us. It's not a controversy. This doesn't mean that temperatures are always going to be warmer everywhere all the time. In the last video, I told you that it got down to -60 in March in the town I used to live in. That's just one point of data, and it's just in one place. Even if that had been the coldest winter ever recorded in South Dakota, that's just one place. What was it like everywhere else in the world? This is what I mean by individual points of data can't give you the big picture. Here's a graph of the global average temperatures over the last 140 years. We can see that from the years 2016 to 2018, the global temperatures dropped. But those are just individual points of data. The overall trend is one of warming. I should add that now we officially know that 2020 was tied for 2016 for the warmest year ever recorded. Sadly though, people think the world revolves around them. It was cold where I lived this winter? So much for global warming, am I right? No, you're not right. We use the data on weather to create models about the climate. They're never perfect, and we've only been doing this for a couple of decades, but we are always improving. Now, while weather produces the data that tells us about climate, conclusions about the climate data can also inform us about the weather. Weather is the effect of the atmosphere absorbing and transferring energy from the sun and from heat radiated off of Earth's surface as well. Because the climate is warming, that means there is more energy in the atmosphere. So we should expect to see more energetic climate and weather events. And we have been. Over the last 100 years, the number of hurricanes that occur every year has not increased, but the number of Category 3 or higher hurricanes has increased. When you picture a planet getting hotter, you might think that means the planet is getting drier. But that's not the entire story. Places around the world that are prone to droughts are likely to see prolonged and more frequent droughts as the planet warms. But a warmer planet is also a wetter planet, which makes perfect sense. More heat means more evaporation. This is why places which experience flooding and monsoons are seeing even more of these types of weather events, or, like with hurricanes, if the number of them is not increasing, the magnitude or strength of them is increasing. There are multiple factors that determine climate. We discussed these in lecture 34 when we learned about why temperatures vary widely from place to place, but we will go over these again. When I say differences in climate, what I mean is why is one place warmer or colder than the other, and to a lesser extent, how much precipitation does a place receive. Focusing on temperature may seem a bit arbitrary, but this is a direct measurement of how much heat and energy the atmosphere receives. It is the most significant characteristic when trying to understand the weather or climate. Ultimately, the differences in heating result from latitude. As you move farther from the equator, the same amount of energy from the sun spreads out over a larger area, so there is less heat. Because Earth is tilted at 23.5 degrees, the tropics also sit at those latitudes. The tropics mark the farthest point from the equator where there is one day out of the year, the solstice, where the sun is directly overhead, which would mean a perfectly straight object would have no shadow at noon. The polar zone is marked at the farthest point from either pole, where on one day a year, the sun either never sets or never rises, which would also be on the solstice. This is because the angle at which the sunlight arrives is obscured by the shape of the planet, in the case of the sun never rising. The tropics and the poles don't have seasonal changes like you are probably used to. The climate in places that exist within these regions stays pretty consistent throughout the year, always hot or always cold. Many places within the temperate zone fluctuate between long hot summer days to short cold winter days. For example, in South Dakota where I live, and many other Midwestern states, the difference between the hottest day of the year and the coldest day of the year can be well over 150 degrees. And this is extreme because South Dakota is a mostly flat state, and that same variation can happen in the same location. For the third time, as I said, in 2019, we reached temperatures of -60, while later that summer, there were days of almost 100 degrees. Here in California, we have Death Valley, where the temperatures can climb to 130, and high mountains, where temperatures can plummet. But those are extremes in extremely different areas. There's nowhere in California where you can see that much variation in the same place. This brings us to the other factors that influence climate. Again, we've covered these, so I'll be brief, but pay attention. Elevation affects the climate primarily because higher elevation means a thinner atmosphere, and the air cannot absorb or retain nearly as much heat as it can at lower elevations. Compare Flagstaff, Arizona to Phoenix, two cities only about 200 kilometers apart, but 1,800 meters different in elevation. Topography has dramatic effects as well. Millions of square kilometers of Asia are extreme desert climate, partially because of elevation, but mostly because of the Himalayas. The Indian Ocean brings huge amounts of seasonal rain, but virtually none of it reaches north of the Himalayas because of their extreme height. This is called a rain shadow. Living next to the coast has a number of effects. Generally, these locations receive more rain than landlocked areas. But as we have learned in the past, living next to large bodies of water helps keep temperatures stable. The differences between the coldest months and hottest months of the year are less in most coastal areas than they are in most landlocked areas. But as we also learned, it matters which coast you live on. Global wind patterns caused by Earth's rotation and Earth's tilt transfer the heat of the oceans in specific ways. So the climate in France ends up being nicer than the climate in Newfoundland. Most of Earth's deserts sit at 30 degrees north or south latitude, which isn't a coincidence. As the large Hadley cells of the tropics push back down at these latitudes, they, in effect, push the air away, which drives moisture in clouds and precipitation away as well. That's why the deserts exist in these places. Vegetation plays a large role in the climate of an area. Dense vegetation, especially trees, tends to make an area cooler than bare ground or grasses do. Typically, the climate dictates what type of vegetation grows in an area, but human activity is so significant that we have the ability to alter the climate in local areas by messing with tree coverage. We've looked at satellite imagery before, but let's look again at New Zealand. Understand that this entire area would naturally be dark green, like it is around the volcano. This is millions of trees lost, and New Zealand is a small piece of this vast global puzzle. A single tree has the ability to soak up several hundred gallons of water and release it into the atmosphere in a single day through what's called transpiration. Without trees, this water remains in the ground. There have been several recorded instances of areas experiencing prolonged droughts after people moved into the area and cut down all the trees to build shelter and make way for farming. Tree pollen also serves as the condensation nuclei for water droplets, which eventually go on to form rain. We will end this video with a brief discussion on climate change. You can find ordinary people, politicians, and scientists who say that climate change is our most serious existential threat. And you will find ordinary people, politicians, but not scientists, who say that climate change isn't even real. Or they will say that human-induced or anthropogenic climate change isn't real. Climates change all the time, they will say. Climate change is a topic that would require its own series of videos, but I don't think I need to discuss all of the ways in which the climate changes. Orbital precession, axial tilt shift, changes in solar intensity, etc. Here's what you need to understand. Yes, the climate changes, but there is always a reason for it to change. And apart from massive volcanic eruptions, global changes in the climate occur at extremely gradual rates. Scientists have looked at every single metric that causes climate change and weighed that against the pattern we've seen over the last 100 years. The conclusion is the extra amounts of greenhouse gas, mostly carbon dioxide, is the primary catalyst of the warming and other climate-changing effects over the last 100 years. For example, the warmer planet is thawing permafrost and releasing methane, another powerful greenhouse gas. But it's thawing and the planet is warming because of the carbon dioxide we are releasing in the first place. And on the global scale, the climate is changing faster than at nearly any point in recorded history. Human activity has strengthened the greenhouse effect. It's not a controversy, it's a fact. This is such a talked about issue that I don't think I need to dedicate my own videos for it. The correct information is out there if you want to look it up. But, in fact, that wraps up meteorology. Next time, we begin our final unit on astronomy, which I am extremely excited for. Thanks for watching.